So let's talk about AWS Inference. Before we understand what it does or what inferencing means, we'll understand the gist of where it's used. On a high level context, AWS Inferentia is used to run AI and ML models on a very high level. Some real world applications being Amazon's own AWS Alexa. And then we have ByteDance, the company behind TikTok. And then we have Anthropic, fantastic minds behind Perplexity, and Skywatch. All these companies use AWS Inferentia. So, what is inferencing? Inferencing is a process of using a trained machine learning model to make predictions or decision based on new or unseen data. It's the action phase after a model has learned from its training data. So how is it different from training? Training is a part where the model learns patterns from a labeled data set. For example, studying thousands or even millions of cat and non-cat images to understand what makes a cat. While as inferencing is a process where the trained model uses what it learned to analyze the new data and predict outcomes. For example, deciding if the given input image is a cat or not. So let's understand what's happening under the hood of AWS Inferentia. Uh, Inferentia uses a custom SoC developed by AWS to accelerate deep learning inference workloads. It's specifically built for inference, which is making predictions with trained models, unlike general purpose GPUs, which handle both training and inference. Think of a GPU as a Formula One car. It's great for racing, which is in the context training the models, and computation and commuting as well, right? You can technically commute on a Formula One car, but it's not very efficient at doing that. For example, as a GPU is at inference. Whereas AWS Inferentia, on the other hand, is like a high-speed train engineered to carry passengers in the context predictions efficiently and at scale. All right, let's take a closer look at what this custom chips consist of. Primarily, they consist of multiple neuron cores. These are the core processing units optimized for machine learning operations, as we've discussed. Within each neuron core, there are three main components, uh, which are scalar engine that manages floating point operations, flops for short. What it does is activations or normalizations, and we have vector engine that handles vector computations, that is pooling or element-wise operations, and tensor engine. It's the core, it's the heart, which executes tensor operations. Example, convolutions and matrix multiplications. The SoC also includes a large on-chip memory to cache models, minimizing external memory access and boosting performance. So let's do a quick recap. Why AWS Inferentia after all? Firstly, it works seamlessly with TensorFlow, PyTorch, and MXNet via the AWS Neuron SDK. Again, it reduces costs up to 70% per inference compared to GPU-based instances. It offers up to 4 times higher throughput and 10 times lower latency. And it's super scalable. Supports distributed inference for massive models using Neuralink. NeuronLink. NeuronLink is a high-speed, low-latency interconnect for communication between the chips that enables distributed inference. You can think this as NVLink for NVIDIA GPUs. I know that are connected on SLI, right? And all of this using only 50% of the power. Well, that's enough of presentation already. Let's get into some action, shall we? So yeah, the project that I worked on is text to SQL. Right now, this is a schema that I've created to create a database so that I could test on. This is event management. It's a part of my group project. And here's a brief details about the schema. We have user tables, venues table, events table, and few helper tables, notifications, tickets, registration, etc. So here's the code. where I'll be using a quantized version of Hugging Face defog SQL Coda model. So using metal performance shaders, as this is a MacBook that I have, and everything's happening locally. I'm running the quantized model locally. We can see here loaded onto Apple Silicon GPU. Approximate memory usage. That's my RAM usage. It took around 12 gigs of my RAM. So let's do some prompts, shall we? For example, here we have list all the events happening in Dallas. I'll just put it here. It's generating query. It's right now what's happening is it's inferencing locally. It's a smaller compute. It's a mobile compute. It's gonna take quite a bit of time. But the use case here is once I have a proper clustered a GPU included a SageMaker instance or a proper EC2 instance, it would have costed me a lot. But using Inferentia, it would only take a fraction of the cost that would incur. So we can see here we have it's defog SQL coda. It's the open source model. It's a 7 billion parameter model, and it did run on the GPU, and it took around 10 seconds to inference. It did generate 52 tokens, which is the SQL query, right? Yeah, it got it right. Let's try something else. How about how many organizers made the most amount of profit? Let's do that. Look, so we do have a result. It did generate a query. I'm sure it's correct, and then here's our output. Let's do one last query. What's total revenue from all the events? And here we go. Thanks for watching.